Scientific notation allows us to write really, really big numbers or really, really small numbers in a shortened format. Eventually, then what we can do is carry out calculations without having to plug in absolutely massive numbers or absolutely microscopic numbers. We can use this shorthand, which is scientific notation. Now, the structure of scientific notation is that we're going to have a value times base 10 raised to an exponent. What 10 is going to do is it's going to either make a string of zeros at the end of a number, or it's going to make a string of zeros kind of before a number behind a decimal place. So adding the zeros at the end to make a very large number, that string of zeros between a decimal place and a number makes a very small number. Now, this value of a, this number that we have here, has to be between 1 and 10. So we want to be very careful about what value we're seeing there for a, and making sure that it can equal 1. That's completely fine. It should not equal 10. And that can be any value in between there. So let's try this out and writing scientific notation. So let's say we have the number 4,000. And what I'm going to think of is, where is my decimal at this point with this number? And it is right here. So my decimal's at the end there, showing this number 4,000. Now what I want to do is move this decimal over until I get to the spot where I have this number between 1 and 10. So if I move it over here, I have 400. If I move it here, I'm at 40, still too big. If I'm at here, then I'm at the value of 4, which is exactly what we want for something between 1 and 10. So I'm going to put the decimal there so I can write a as 4.0. And I'm going to go times 10 and see if I have this 4.0, how do I need to move that decimal place to make it 4,000? Well, I'd have to go 1, 2, 3 to the right-hand side. So with that, I'm going to write down an exponent of 3. And these are equivalent values here. Let's take a look at how this works with 0.004. So I have my decimal there. If I move it to the right one, I have a 0.04. If I move it right again, I have a 0.4. If I move it right again, I'm at 4. So I like having the decimal there because that matches my between 1 and 10 idea. So what I could do is rewrite this as 4.0 times 10. And when I'm at 4.0, what I need to do with that decimal place is go 1, 2, 3 to the left. So this time I'm making it a smaller value. So what I'm doing is I'm moving it 3 spots, but I'm going to use a negative symbol to kind of show that I'm dividing by 10. We're dividing away 10 to make it smaller and smaller. So those are 2 forms of our scientific notation, with a larger value and a smaller value. So let's go ahead and practice writing out our scientific notation and converting between the 2 forms. So we have distance to the Andromeda galaxy from Earth is this massive number that I don't even know how to read out loud. But what I want to do is, seeing this numerical part with 2 and 4, what I'm thinking about is, where should I be putting my decimal? Well, if it's there, it's a 0.24, that's too small. 2.4, that's perfect. So what I want to do is, for a, write this as 2.4. And then this is one of the few spots in math that we're using x as a multiplication symbol. It's pretty special to scientific notation at this point in our math work. Just a side note, when you're in MyOpenMath doing work, it will likely want you to use the dot multiplication symbol. So in MyOpenMath, it'll look like this, but just for the sake of writing, we typically use the X symbol for multiplication. When you use X in MyOpenMath, it might look kind of curvy like this, And it's because it's using a variable of x. It isn't using multiplication, and that's what we want to be careful of. Okay, times 10, and then I need to figure out how many spots am I moving to the right-hand side. So I'm going to look at these groups of 3 to help out, because what I need to do is end up over here. So 3, 6, 9, 12, 15, 18, 21, 22. So we need to move 22 spots to the right-hand side. And there's our scientific notation. Okay, next one with the diameter of an electron. So I'm looking at where I have this 9 and 4. I just need to think about placement of my decimal, and I would want to put it right here so that I'm working with the number 9.4. And then we're going to go times, and then I need to figure out how do I move from where I have my decimal with 9.4 to where I need to be. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And with this, I'm making the value smaller by moving to the left. This is going to be a negative 13. All right, probability of being struck by lightning in any single year. And let's see, I'm seeing that 1, 4, and 3. I need my value to be between 1 and 10. So I'm thinking 1.43 is going to be perfect for my value of A. Times 10, and then I need to figure out how I'm moving my decimal. So I go 1, 2, 3, 4, 5, 6. And that's in the smaller direction to the left, so that'll be a negative 6. All right, so that's how we can write scientific notation from a given number. Now let's talk about changing to decimal form. So I'm starting with my 8.6. And what this is telling me to do with that negative 5 is I'm going to be moving to the left 5. So I'm going to go 1, 2, 3, 4, 5. That's where my decimal is going to end up, and any blank spots are going to be filled in with zeros. So this is going to be 0 point, and I'm going to have 4 zeros and an 8, 6. With this 2.45, I'm moving my decimal to the right because it's positive 6 units. So I'm going to go 1, 2, 3, 4, 5, 6, and then fill in the blanks with zeros. So I'm going to have 2, 4, 5, and then 4 zeros. And then we could use some commas to separate up that number up. Okay, 1.02, and we are moving to the left 7 units. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So we're going to have 6 zeros there before the 102. 1, 2, 3, 4, 5, 6, 102. So there's an introduction to our scientific notation and how we can convert between the two forms.